Okay, so let's open SQL developer. Okay. All right, let's log on to database. Okay, so let me say the question. The first question is, give $200 commission to the person who has smallest salary in his or her job title. Oh my God. That's why you ask question. That is something we are going to do today, but that is not supposed to be there. Okay, let's say without the concept of tuple variables, let me see whether we can do it, okay? Let's see, give $200 commission to the person who has smallest salary. Can you find the person who has smallest salary in his whole job title? So let's try to do that. I think it might be a good idea, just introduction to that. So this question, I will forget that when I do grading, because this let me look at the next question. So it might be similar nature. It was supposed to be a question for today's class. For each clerk or sales, give each clerk sales salary increase, which is 3% of cost average. Okay, that one probably okay. Okay, this one is okay. So let's do this one. Let's do the next one first. Okay. So first, let's give each clerk salary increase, which is 3% of average salaries. Okay, so update, EMP, set, cell, salary increase. So that means salary plus, so plus what? 3% of all clerks' average salary. So how much is that? So that basically is just equation, right? Question mark. And then we are going to give that to all clerks. Okay, so now we replace the question mark with that subquery, trying to find out what is 3% of all clerks' average salary, right? So that one is, so select 0.03 times average of cell. Okay, from EMP, now where job is equal to clerk. Okay, so that would be so this one is not is within your reach, but the one before that is not. I will let's try to do that. Okay, let's try to do the question. This one. See whether we can do it without using the concept of tuple variables, which we are going to cover today. Okay. So first of all, let's try to see how can we find the person, find the people. Okay, people who is making smallest salary, who has the smallest salary in their job title. So you understand that the question here is asking, so for example, for salesman, okay, you find one salesman that has smallest salary, okay? And then for accountant, trying to find the person that who has smallest salary, who has job as an accountant. Do you understand the problem? Okay, so now this is the problem you were trying to do, okay? And then you'll tell me whether this is correct or wrong. So we'll say select e-name, okay? Select e-name, and then from EMP, okay? And then say, well, say we want to find the salary, which is smallest salary for his job, right? So I will just say, well, let's try to say find smallest minimum salary minimum cell from EMP, then group by job. Okay, so here the subquery is trying to find minimum salary for jobs. Okay, minimum salary for each job, and then you're trying to find an employee who have salary in that list. Okay, so can you tell me whether this is correct or wrong? Well, you can run it. You should run. Okay, so you find those people. And if you also want to have that job title listed, and then those are the job titles. All right. And if you also want to show their salary, you can do that too. Okay. And then the question is whether this is what you're looking for. Whether this, the people have smallest salary in his job title or not. Does everybody realize the issue? This is not correct, even though, given the data here might give you a right answer in some sense. However, this is incorrect query. Why? Let me give you this idea. Okay, let's try to do that in the whiteboard. Let me show you. All right, so now let's say, suppose I have 3 departments. Okay, let's say accounting, the minimum salary is 3,000, okay? And now let's say I have a management, the minimum salary is 2,100, okay? And let's do one more, let's say marketing, the minimum salary is 2,900. Okay. Now, let's say suppose a person who is accountant, who is let me just try to say that who is in management department. Okay. Suppose a person who is in management department, a person in management department. Okay. And makes $3,000 salary. Okay. Is this person make the minimum salary in his department? Yes or no? No, it's not, right? This person is making 3,000, but the minimum salary for management is 2,100. So clearly this person should not be selected. However, if you're trying to find, so if you do say select ename from EMP, and then say, well, cell is in what? In this list. Okay, this gives you the minimum salary for each department. So let's say this is 3,000, 2,100, and 2,900. You will say that this salary, the person you're looking for, does match one of the salary, which is 3,000. However, this person is not what you're looking for. So even though this query may give you some result, the result may be incorrect. So here I'm assuming that we're trying to find the minimum salary, the person who makes the minimum salary in his department. Okay, you can just change it to job title in the same way. So this is accountant, this is manager, this is like a sales something, all right? So you can change it to job title, which is basically the same thing. Does everybody understand the issue? So this is not correct. Okay, so this solution is not correct. Okay, so why is not correct? It's just because the salary, you're trying to find a salary that in this range, in this list, but that list does not guarantee that you are matching this person's job with the minimum salary. Okay, so what we could do is instead of just matching salary, we can also match in both salary and also job title. So what we can do is this one. So do job parentheses, okay, and comma, and then parentheses here. So basically, I want to check both job and the salary, and to make sure that that is in this list. In the list. Then so we're looking for the job and their minimum salary. So if we're matching the job title and also the minimum salary for the job title, then that person should be the one you're looking for, right? So now this would be a correct one. Okay, this would be correct. So now let's say if I need to finish the original query like this, okay, give $200 commission to the person who has smallest salary in his job title. So that means you're not giving $200 commission to just one person. You probably have to do that for every person. Okay, every person who. Let me just run this one here first. So we find 1, 2, 3. Those people are making smallest salary. So we have 2 analysts. Why? Because they both make the same amount, 3,000, which is minimum. And this manager is 2450 minimum salary, and then president 5,000, and then we also have 2 salesmen making exactly the same thing. Okay, so now the question is we have to give $200 commission to all of these people, not just one person, right? So let's try to do that. Okay, so we'll do update. Okay, update EMP set count equals 2. So just make sure that we may have existing salary, or maybe there is also like a missing values. So I'm going to use MVL to handle the existing commissions. If the existing commission is missing, then we'll change it to 0. Otherwise, I'll just use the existing commission. And then plus 2,000, right? 200, sorry. 200. Okay. And then we say, well, EMP number in, and then we are going to use subquery, which is basically just the one we had before. Instead of looking for employee name, job title, and then you just search for employee number. Okay, so we'll do select EMP number. Okay, then from EMP, well, then we have the match job and also salary for that person is in another subquery inside. Okay, which is trying to get the list of job title and the minimum salaries. Okay, and then we close the whole thing. Okay, so now we need to finish the subquery here. So that would be select job, and then min cell. Okay, from EMP, and then say group by job. Okay, so now this will be the way to solve that problem without using concept of tuple variables. That's what we're going to do today. So in any case, this question 19 will not be graded. Okay, and then just I don't know why you guys don't ask me during when you do this. This is not clearly, we have not done something like that yet, right? So you actually you can link not just single value, but you actually can compare just like multiple values, and then to say whether there's multiple values in this list. Okay, and so these unknowns is slightly more complex than the one we did before. Okay. All right. Thanks for raising that up. Otherwise, I won't realize this question. So I need to, you know what? I'm going to change this right away. Otherwise, I may do the same thing next year again. So that's homework. That's week 8 outline. So we're going to get rid of that question 19. Okay, Let's see that. Now, do you have any other questions that is in similar nature? After I do grading, I will realize that. But now, if you know some questions, it's kind of in that nature that is difficult. Can you let me know? So let me put this question to another homework. Week 9, maybe 10. That 10. Okay, here we go. Any other questions? Did you get 19 correctly?
No.
No. If there's no more questions, I'm going to move on to today's lesson. Okay. Today we are going to do something called tuple variables, and also we are going to do something a bit simpler, like how to copy data from table to table, and how to use expressions systematically, and how to combine the results from multiple queries. All right, so we're going to do week 9 another line. I think I put like a week 10 another line first, and that was wrong. Okay, and let's do week 9 another line first. Okay, so first let me minimize this. Minimize this first. Okay, so let's talk about union, minus, and the intersect. So those are the operations you learned in probably primary school, right? And, like you draw Venn diagrams, trying to find the unions. So let me show you what are those things. Okay. Okay. So let's say if you have one set, this is A here, okay, and then there's another set as B here. This is a Venn diagram, right? And then this part means this part are the elements that belong to both A and B. So A is a set, B is a set. Set basically just a bunch of elements inside, right? Bunch of things inside. So this part will be considered as their common elements. Okay. So to get this part, we are going to use intersect, right? That makes sense? All right. So if similarly, if this is A and this is B, all right, and then if you're trying to get elements in either A here or B here, so basically this or, right? Okay, so then you are going to use operation called a union. Okay, so this part, this is interpreted end in A and in B, right? So this end. Okay, and then if we have A set and there's B set, if we just want to find out the elements that belong to A but not in B, like this one, this part, but not in B. So this part belongs to A but also belongs to B, right? So we're just trying to find A not in B, A but not in B. Okay, in A, not in B. So in that case, we will use something called a minus, right? So this A minus B, okay? And this means A union B, okay? And this means A intersect B, okay? So intersect B, just find those common elements. So this is what you learned in primary school about the set operations. You use a Venn diagram, right? And we can do set operations in SQL too. So in that case, what we interpret these A, B's are just simply set of results. Suppose you have one SQL statement, get results A, which have multiple rows, right? Multiple records. And B has another set of results, And if you want to find the common results, then this will be the common results belong to A and B will be in here. Make sense? Or if you want to find the result either in A or in B, so just say you want to find the result, find the common results could be either A or in B. So you have two SQL statements, right? And one SQL find some results, and another SQL statement find some different results. And then you say I want to find the results that could be in either one, okay? Could be either A or B. Then we'll do union, okay? And minus is similar. So if we have a set of results from one SQL statement, but I want to make sure that the results not in B, okay? So just give you a common simple example here. So for example, if I'm going to create assignments, right? Create a homework. Homework is going to have a bunch of questions, right? The question will be taken from the question library. Okay, so I write one SQL statement to get all these questions, right? Get all these questions I want to put into assignment. But then I want to make sure that those questions have not been assigned before. So I will minus those questions that have been already assigned in the previous homework. So that way I will be only using this part only for new assignments. Does that make sense? Okay, so this is what minus unions are all about. Okay, so let's try to, let me close this one, and then trying to follow this to do a bunch of example here, okay? Let's say first example, let's try to find employees and their annual income. Let's say I will not use MVL functions, okay? MVL functions. So if we do not use MVL functions, then we are going to have problems. Let me show you that, okay? So let's see. Let me copy this question first. Okay, so we are doing union, intersect, and minus operations to combine SQL results. Okay. So first question, show all employees and their annual income. So let's just try to say the annual income include salary plus commission, right? Salary will be 12 months times salary. So we'll do select 12, multiply by cell, okay? And then we plus commission, right? And then from EMP, so that is basically a simple statement. However, this will not give us correct result because we have employees who have no commissions, who have some employees does not have commissions. Okay, so here you see that, well, let's just also put employee number, employee name maybe, okay, along with that, employee name, e-name, along with that. So let's just also make this make a new name, new title. So let's say that's income, okay? Now let's say that, okay, so Kim, no. Jones, no. Ford, no. And Alan has salary, has annual income, Ward has some. So you see that the problem is when we add something to like a missing value, and some commission is missing, right? So if we add any value, any operation involving missing value, the result is going to be missing, okay? Just think of the garbage plus anything, garbage, operation involving garbage, result will be garbage, right? So that's the same idea. So what we can do in this case is we can, for example, we can do that when welcome is not null. Okay, so that will give us correct result for people who have commissions. So those will be the result. Okay, those people who have commissions. So you'll get annual income correctly. But what if the people who have commission, who have no commission? Then you just simply select ename, and then comma, and then you do 12 times salary as income, right? Because there's no commission for those people, EMP. And then say where com is null. Okay, so this time you will also get a correct result. Okay, so those people you will have, well, we do have one person who has no commission, no salary. Okay, the Lisa person has no salary. Okay, so that's what when we trying to create a new employees, when we learn insert. I think we did not finish this record. So we say that we have, we can write 2 queries and then, they both get correct result. However, according to the rule of SQL programming, you cannot write 2 queries for one statement. Okay, so what we can do in this case is we can combine the results from here and here. So basically, we want to get all the results, either from this first set and also from the second set, right? Does it make sense? So we can use, in this case, we can use union. This is how we use union. So we put each query inside parentheses and delete the semicolon. Okay, delete semicolon. Like that. And then we put a union in the middle. And then finally semicolon. Okay, so now you see that the first subquery give you list of employees and their annual income if they have commissions. And the second set will give them will list those employees and their income when they have no commissions. And then by combining both together, and then we should get a complete result. Does it make sense? So this example shows how we use union. Okay, so basically just each subquery, just think of each subquery get a bunch of results, and then on the other side give a different set of results, and then you union. And then when you do this, make sure that these names, what the columns must be matching. For example, the first one I use ename, the second one is income, and for the second result is I also have the same thing. The first column is ename, second column is income. Okay, so if the column does not match, then you get the result, which may not make sense. Okay, may not make sense. All right, does it make sense? So that's how we do union. Now let's do example 2. Example 2 and 3. Example 2 and 3 use another table which I do not have. But you can just go to, you know what, let's just do that. Okay, do that quickly. So go to, I think it's public, right? Equals learning resources, script generator, script loader, right here. Okay, so let's look at sample SQL tables. The one, let me look. So the one should be just creating a table called students. So this requests, responses, and then let's publish your database. Are you following me? This HR database, that's what we are using. And then we are moving down. Let me see. I think this should be one. So here, create a student database. Okay, so I'll start from here. Create a student database. Start from here. And then let's move all the way down to it's quite a few tables. Okay, before before create audit and other tables. Okay, so copy all that. Now let's go to SQL and paste it. Okay, so then this time I'm going to select all of them to run. All right, great. I'll select all of them. Make sure it's complete selection, okay? And then let's run. So now all the tables are generated. Are you okay with me? Yeah. And then you can run it again. So I'm not going to do that. Just delete that. And now let's try to do example 2. Let me know if you need more time. Do you need more time? Are you there?
I got it.
Got it, okay. Does everybody get it?
Yes.
Okay, good. And now let's copy question 2 and then trying to do that. Okay. So example 2, we need to find ID and the name of each employee and the student from EMP table and the student table. So what does it mean? So basically we find ID and the name of each employee and the student. So basically we are just doing the join, doing the union again. So let me look up, we know employee table, right? The employee table. We are familiar with that. But now let's try the employee, trying to look at, so employee ID, employee name, and employee that, okay? And then for students table, let's try to say what are the IDs and the names. Okay, so for students table, we have ID column, and also there's a first name and last name. First name and last name. Okay, you see that? First name, last name. So I'm going to generate some kind of a list, and that will show all the IDs from both from students and also from employees. Okay, so let's try to do that. So first, let's try to use subquery to find out ID for employees. So let's say EMP number as ID, okay, and then the ename as name, okay, and then from EMP, okay, and then we do union, and then do second query. So the second one, we are going to do ID from students table. Select ID, okay, and then name. So this time we're going to get first name and last name together. So let's say first name, and then let's put a pipeline, and then put a space in the middle, and then single quote, space, single quote, and then pipeline again, and then last name. So we're combining both last name, first name. And then let's say that is as name, okay? From students. So this one basically just demonstrating union again. So basically it's not that interesting. Does that make sense? So let's run that. So we get a bunch of employees' names and the students' IDs names all matching. Okay. And then their case does not match. Case does not match. So you can actually change to uppercase if you want to. So for example, if I do, if I say upper, inside, put everything inside here. So then we change everything to the capital. Okay, let's run that. Okay, so that shows how we do example 2. Okay, pretty simple, right? So this one. And then let's do example 3. Okay. Example 3, we find those employees whose name is the same as the last name of some students in student table. Okay. So what does that mean is we're trying to find a list of employees whose name is matching the student last name. So we are trying to do what? Trying to do like an intercept, right? Intercept. So this is just a common names. Okay. So first we'll do select ename from emp. Okay. And then we do intersect. And then second one we'll do last name, right? Last name. So actually we have to do change it to uppercase first, then last name, because otherwise you're going to have a case mismatch from students. Okay. So this shows how we do intersect. So we find a Smith. Okay. All right. So those are this pretty simple demonstrations. So now let's do example 4. Okay. So this time, let's say I want to find a department that has no employees. Do you remember the question? We did that last time, right? So the solution we did was this. We do select dname, right, from DEPP, where DEPP number not in. Select DEPP number from EMP, right? So that is what we did in the last class. So now let's say whether now we can use this. Actually, we can use this set operation to do the same question. So what we could do is say we can find all the department numbers for departments, and then minus the department numbers that belong to that is the employee table, and then those departments will be the ones that have no employees, right? So we do select DEPD number from DEPD, okay, and then minus. Then we do select DEPD number from NP. See that? So first we'll I'll get all the department numbers, and then we'll get those department numbers that shows up in that the department numbers that show up in the employees table. And then the difference will be the ones that does not have employees, right? And we got the department 40 does not have employees. Okay, so we use example to demonstrate all of these cases: union, intersect, and also minus. And now let's do one question, which I think is most interesting. Okay, so let's try to do put that question here first. Okay. So the question is, how much is needed to have like a 2% annual increase for all salesmen, 4% for all clerks, and 6% for the rest of the employees? Okay, so if you're going to use Java or C# or this kind of programs, then this question is very easy, right? So basically, just for each find source for all the records, and then look at the job title. If job title is salesman, you just give 2% salary increase, and then you add that to the sum. All right, so that would procedurally that would be how you do it. But now without that, how can we do this question? How can we do this? Okay, so I'm trying to do this. First of all, let's just try to do, let's say how much salary increase we need for salesmen, and then for like for clerks, and also for like for others, right? So we can do each one individually. So let's just try to do that first. Okay, select, and 2% for salesmen, so that would be 0.02 times then salary increase, right? So the salary from EMP, and then where job is equal to what, salesman. So that would be the increase, the amount you need for salesman, right? So if we use this, let's just say this is as increase, okay, as increase, okay, as increase, and then if we use this as subquery and then trying to get sum of this, then we'll be able to find all the total amount, right? So let's just do that. Okay, say select sum of increase, okay, and then from what? From this as subquery, this whole thing as subquery. You see that? That will give you, so this. So basically, we are using this subquery to create like a temporary table, and then we're trying to use that temporary table to compute the sum of these increases. Does it make sense? Okay, so that will give you the total salary for salesmen, and then we should also do that for what? For clerks, right? So we can do union here, right? So we can just do union first. And let's do this one. So this is, okay, let's try to put this into one subquery. Okay. And then we union. And then let's do the second one. Select, and that would be 0.04% times salary, also as increase. I think I misspelled something here, right? So if you misspell, then you're going to get an error message anyway. So from EMP, and then say where job is equal to clock. Okay, so if you use this union to to create like a temporary table, and then trying to compute the sum, then you'll get those get a total salary increases for both salesmen and also clerk, right? And we don't have to stop here. We can do another union here. We can continue. So let's do this time. Let's do for everybody else. Okay, select 0.06, right? 6%, and then times salary, and then as increase also from EMP, and then this is for everybody else. So that means the job title is not a salesman and not a clerk. So we can say job not in. So let's put inside the parentheses here. One is clerk, okay, and the other one is salesman. Okay, so put that into list, not in this list. Okay, so that will handle everybody else, and then this whole thing will be a subquery, right? Whole thing will be subquery that from which you're going to do the sum. Okay, and then semicolon. So then this is complete statement. And we will get the result, but the result is not correct. Let's run it first, okay? So we get a result like 1197.5, but unfortunately, this is not the correct result. Does anybody understand why this will give you a wrong result? That's actually related to your to set operation, to union. Okay, the concept of union. Okay, let me show you what okay, the union again. Okay, so let's say if I have two set, okay, suppose I have two set. The first set A is equal to, let's say, 100, 200, and then 50. All right. And now let's say B would say B is, let's say, 100 and then 300. Okay, let's just say these two, right? So then what is A union B? A union B will be 100, 200, 50, okay, and 300. You don't repeat this anymore, right? Do you? So that's a union. When you do union, you only get those distinct elements. So in other words, when you do like a result, you have like a union as a result. So if result, if there's a common result here, if result is common, it will be only showing up once in the union. Okay, so for example, if one result coming from A and also from B, and that result will not be showing up twice. Okay, but that would be probably for ours. Okay, so here, if I found one salary increase for salesman, let's say the salary increase, like say, assuming that is 100. And then for the second one, you also find 100. And then when you do the union, you are not counting those separately. You're only counting them once. Make sense? So that 100 will be only counted once when you do the sum. We do the total here. Does it make sense? So that's why this actually is not this is not correct. Okay. However, how can we make this correct? Actually, it's pretty simple. We can make it correct, and that is what we do is say for each employee, right? So we are doing that for employee, right? So if we get the salary increase, and also what if I just also show the employee ID, EMP number, along with the increase. Okay, and do the same thing here, EMP number along with increase. And then EMP number and also the salary increase. Then you will not have any situation like that. One row is appearing this identical rows appeared in two different queries, right? Because each department, each employee number is unique, right? And so for example, employee 1001 has 100 salary increase, and another employee 1002 has also 100, but that two 100 will not be merged into one because they will be counted as separate rows. Does it make sense? And that finally, this is correct result. All right, so let's run it. And then let's say previously we had what, 1197, right? So now let's see whether we get the same result. No, we don't get the same result. So actually the correct result is $1,444. So that basically say manager, executive say, I want to know how much salary increase I need if I do this kind of, this kind of salary increase scheme. Okay, and then you don't have to wait for data to be dumped into data warehouse and have a programmer to write a code, and so you just write a simple SQL statement to get this result. Okay, so as a manager and as an executive, you have data from real database, from transaction database, which is live and is ongoing, and it's better to use this kind of a mechanism to get the result instead of waiting for so long, like a half month or maybe a couple of months for the program to be coded, and then eventually after the time, the information may not be useful anymore. Okay, so anyway, that is the last example, I think, showing how to do union stuff, do union intercept. Okay, make sense? Does anybody have questions so far before we switch to next lecture about tuple variables? No questions? If there's no question, let's move on. So let's talk about the tuple variables. Okay, tuple variables. So SQL. So remember, SQL is a non-procedural language, and basically you cannot declare variables and then assign values to variables, those type of things. However, there's one type of variable you can use that is so-called tuple variable. So you know what's tuple, right? A tuple is just simply a row or record, right? So we talk about that, the three different terms used by professionals. And the tuple is more like an academic term for row. Row is like for people, for like a layman person. And record is for information processing professionals, right? So tuple is representing, so if I have a table like this, a table, okay? And then tuple is just representing a row, okay? So for example, this tuple T, and this T is actually representing any arbitrary row inside this table. All right, and that tuple can basically, can be changing from first row to second row, third row, can be any row. Okay, so that's representing the whole it's just like a whole record. Okay, so that's what tuple variable is representing. Just make sure that you, for some of this advanced SQL stuff, we do not have a write-up. On my lecture note, I have been trying to create more chapters after this, but then just still not found a very satisfactory the whole time to do that. So basically, I'm going to just explain and then use examples and explain along the way. Make sure you pay attention. Okay. I think the tutorial I give to you on e-course does have a little bit of knowledge about the tuple variables. Okay. So let's try to use the example to see how can we use tuple variables. Okay. So first example. So let's just try to copy this also. So here we're trying to create a directory that shows employee names, jobs, departments, as well as the names of managers. Okay, now let's try to think. So I think it's pretty easy to get the names and jobs and their departments. So we'll just say select name, right, and the job. Okay, and the department, we can use department number. Okay, and now if we want to get a department name, then we'll have to use join, right? We'll have to join a department table. Okay, but then how do we get a department? How do I get a manager's name here? Do you see the problem here? So we cannot use the manager MGI. MGI is just manager number, right? But we want to get a manager name. Do you see the problem? Does everybody understand the problem here? So if we're going to just say this, select this from EMP table does not have something called a manager's name, right? So what we could do is the managers are just employees, right? Managers just employees. So what we could do is I will use those managers' employee name, right? So how do we get that? So this is what we do. We're just trying to come up with from first, okay? Let's just say from EMP A, and then EMP B, and this A, B are tuple variables. And now I will reference to this A, because we're using two tables, identical tables, right? This is from table A, and this from table B, right? So I have to specify which column we're talking about. So A.ename, and A.job, and A.dpt number. Okay. And then from B table, I'm going to just get employee name also, but those are for managers. So I'm going to just get a B.ename as manager. Just that, okay? Like that. And then we have to make sure we link these two tables because we have two tables referenced, right? So we have to make sure that A dot manager's number is equal to B dot EMP number, right? So that's how this table, the employees and their managers are connected. So the managers. So we just simply consider B as a manager, okay, A as employee, okay, and now so let's try to use different. So we don't have to use A and B. Let's just try to use different name here, okay. Let's just say this is subordinate. Okay, and the B is supervisor. Okay, so we interpret A employee, the same employee twice. Okay, the one using tuple variables, one is subordinate, another one is supervisor, and then we change this. This is subordinate, ordinate. Do the same thing here. Subordinate. Then subordinate. So those are the employees are looking. We are looking for those subordinates, name, job, and the department. And then we also want looking for their managers. So for managers, that would be supervisor. Okay, and now we have to make sure this is changed. Subordinate's manager number will be equal to the supervisor's employee number. Supervisor. Okay, so this subordinate is name of tuple variable, and this is another tuple variable. Okay. So this the first use give you example showing that using tuple variables you can select records from same table twice or 3 times or multiple times. Okay, usually without tuple variables that's impossible, right? So for EMP, then you cannot say comma EMP again, right? So however here you can just just give just create like a different aliens different name for same EMP records, right? So let's try to run this and then see whether you have any questions. I think we have invalid identifier DEPT number subordinate. I think I misspelled something here. Which one? Right here. Subordinate. Okay, let's run it again. All right, so now you see that Scott, analyst, department 20, Jones. Okay, look at that. Okay, is that cool? So basically give you, so the first use of your tuple variable is just basically allow you to query the same table multiple times if you needed to. Okay, now let's see whether we have more examples showing doing that. So next one, find employees who have, okay, so we are getting to the problem like we were handling before. So we can just do any of those. So let's see. Let's just do this one. This one might be, this one is a little bit more complicated. Let's do one simple ones first, okay? Do simple ones first. So first, find employees who make the largest salary in his or her department. Okay, so remember at the beginning of the class, I showed you can do this way. You can just do solution like this. You can select ename, okay, from EMP. Well, so So this time we have to make sure that the salary and his department number must be in the list of minimum salaries and the corresponding department. Okay, so we'll do a subquery like that. So mean cell, and then comma, and then DEPT number from EMP, and then we say group by DEPT number. Okay, so this subquery gives you a list of department numbers and their corresponding minimum salaries. And then as long as the salary and the department number matching one of those, then those are the employees you're looking for, right? So this is, we said we can do that without using tuple variable, which we can just use something like a simple subqueries to find this, right? But now the question is, let's try to do tuple variables, okay? Trying to do tuple variables to see how we use tuple variables to do this problem. So this to do that, let me show you the idea, okay? So this is what we were trying to do. Okay, so let's just use this whiteboard. Now let's just imagine we have EMP table. So EMP table have EMP number and E name, right? And a bunch of other columns, and also salary, right? And then department number here, okay? So then, and then say, let's just arbitrarily pick up a row here. So that, let's just say that is tuple variable T, okay? Tuple variable T. And so what we do is we are looking each record. So the tuple variable allows us to vary from row to row, to change from row to row. It's a variable, right? It's changing from record to record, from tuple to tuple. And then for each T, I'm going to use another table, which is the same EMP table, okay, which have employee number and then E name, and then also salary, and then we look at that. Looking at the department number here, the PD number here. Okay, so then just say we have another table. Let's just say that's S. Okay, tuple variable S. All right. So what do we do? How do we do this question? So we use this first tuple variable, first table, to look for each record, and then for each record, I'm going to do this. I will consider their salary. So suppose salary is 2,000 here, and then what department terms here. Okay, and then I'm going to use this to come to the second table to search for department terms. So department 10 here, department 10 here, and department 10 here. All right, and then from that, for this department 10, for this using tuple variable S. So this is the S will be changing from here to here. Okay, so after you look at that table, look at this second table, and then you just trying to say the department 10. What is the minimum salary for department 10? Okay, so if you found that that record is matching one of the minimum salary for department 10, then this record will be selected. You select that. If not, if for department 10, you look at department 10, that but does not match the minimum salary. This, the minimum salary, for example, is 1,500, right? Then this record will be skipped, and then you go to next row and check it again. So look at department 20. Okay, the department 20 may have like a salary 1,500. All right, and then you do that again. So pick up a next record and then go to this table to looking for department 20. So department 20 might be somewhere like here. Let's say this is department 20 and this is department 20, and this department 20 has a salary, and let's say salary is like 1,500. Okay, and then this department 20 has salary like 2,500. So different employees, right, belong to the same department. So let's say I will check, say whether this is matching this minimum salary for department 20. If it is, then this record will be selected. Otherwise, we skip it again. Okay, so that's how the tuple variables can be used to find the solution that we are looking for. So you may ask, well, if we have a simple solution, why do we need to use tuple variables? Well, the answer to that question is the solution we provided before, that using like a combination of department number and the salary, does not work all time, does not work always. And you will see examples like that, okay? So tuple variable is more powerful than that, that approach. Does everybody get that? Okay, so we basically we are going to use use the tuple variables. So use a subquery subquery and also tuple variables combined. Okay, to do that, to do search. So now let's use example to demonstrate the example, and then we're going to give you a few questions that you can you can do the drill. Okay, so let's say I want to do select ename. Okay, so first of all, let me do tuple say t.ename, t.ename. Okay, and maybe also do salaries. So if you want a salaries too, from mpt. Okay, tuple variables, right? And well, so now we need to check so t dot cell is equal to what? The minimum salary for department T, for T's department. So what's T's department? T's department is T dot DEPT number, right? So we're trying to find out what is the minimum salary for this department. And that we'll use a subquery to do it, okay? So we'll do select. Let's just say minimum salary, so mean. If we're doing minimum or what? Largest salary, sorry, it's largest salary. So actually we should change to max. Max salary. Sorry for this. I misread the question here. So basically this largest salary. So we're going to do max here. So select max of, let's say use another table that's at s dot cell. Okay. From emp s. And then well s dot the PD number equals to t dot DPD number. So now you see the question like what I explained to you. Okay, so here we are using tuple variable t from just pick up one record from employee table, and then we check the salary. Okay, and then say whether that salary is the maximum salary for that T's department. Okay, so this subquery is going to check that, right? Subquery is going to check for every row from table T, table S. Okay, say whether so that whether the S department, if you match S department number equals to T's department number, and say what is the maximum salary. If that maximum salary match, then that's all you need. That's all you need to know, right? Okay. So let's run that. Okay, so we found that those people who are making maximum salary in their corresponding department, in their respective department. Okay, so that should give you the same solution if you run this one. Okay, now let's try to do this with a different, just trying to change do different variations. Okay, so do a drill. Okay, first find employees who make smallest salary in his job. Okay, just try to use this model to create the query, to write a query, and then we'll see whether you can get it. Do you get it? So if we're going to do that, just follow the same model here. We select T.enum from EMPT, and then we just make sure that T salary is the minimum salary. So what is the minimum salary for T's department, for T's job? Okay, so we're going to select the minimum of S dot salary from EMPS, and then make sure the S dot job is equal to T dot job. Okay. Get that? Okay. Now let's say whether we can come back to the example we were looking. So we did the first example. What is the second example? So this is actually, okay, so this is example 4. That's the one we just did, right? So example 4 is the easy one. So let me copy that and then just see whether we did that. Okay, so find an employee in each department who has the smallest salary in the corresponding department. I think we did the opposite. We did the largest salary, right? We find the employees who make the largest salary in his or her department. So here we are finding the minimum salary. Okay, so it's kind of the same question, so I'm going to skip that. Okay, so now let's switch to going back to example 3 here. Okay. Okay, so example 3, find employees who have the longest history in the company in each location, at each location. So what does it mean is we want to find an employee at each location. We want to find out at each location, we find out that there's one person who have longest employment history, who was hired first, in other words, who was hired first. Okay, and each location should have one such employee, right? And then we're trying to find those employees out. Does it make sense? Okay, so now let's try to do that. So I'm going to, so since this time we are going to use locations, so probably we have to use multiple tables. So let's just use tuple variables with multiple tables. Okay, so we do, let's just say T.enum. Okay, and let's use this second variable. Let's just use S dot location. So 2 tables. Okay, 2 tuple variables from EMPT, comma DEPTS. All right. Of course, when you use 2 tables, then you have to use equal join, combine them, right? So then say, well, T dot EPT number equals to S dot EPT number, right? Okay. So that is the first part. So basically, we're trying to look at the employees and their location, and then those employees will be the oldest employee, oldest one in their corresponding in the corresponding location. Okay. So now we have to make sure that at T dot hire date is minimum hire date for the same location, S. Okay, so we are going to use subquery to find out. So select minimum. So this time let's use T as, let's just U as U and a V. Okay, U dot hire date. Okay, U dot hire date from. So we are matching hire date, right? Hire date with this minimum hire date from EMPU and then DEPTV. Okay, And then of course we have to combine them. So u.dpt number equals to v.dpt number. Okay. Make sense? Okay. And then we have to make sure that the higher date, the minimum higher date we are looking for is the one same as t's is same location, right? So it's same as location. So as and so where and as, and then what is this? Actually, we are using different variable here. Department department is v. So v dot log is equal to and s dot log. So kind of a little bit more involved here. Okay. So let's check this logic again. So we are using equal join, and then trying to, so basically we are using 4 tuple variables, 2 for EMP table, 2 for department table, okay? And then when we do the equal join, we get the employee name and the location. So this location is the one that we are looking for minimum hire date. So as long as that the employee we are looking for, that employee T we are looking for, whose hire date is the minimum of U's hire date, and the U hire date, of course, U.dpt number must be equal to V.dpt number. So this matching allows you to check that this department are matching. Okay, and then this is the location are matching. So inside the subquery we are looking for those employees, looking for the minimum hire date for the department for this location, okay? And then we match this location to S that location, okay? So that's why I said this one is slightly more complex than the other ones. So let's run that. So we have Smith, Dallas, Allen, Chicago, Clark, New York. Okay, does anybody have questions? Now let me try to show you examples that really need to use tuple variables. The previous previous technique will not work, like using job, comma, salary in the list will not work, okay? So let me see whether we have an example like that. So, okay, let's do this one. Find the name of employees who have salary more than average of their respective department. So this one actually match works. Okay, example 6 will work. Okay, so if you're trying to use the previous technique like this, so let's say select ename from EMP, and then say, well, let's put a combination here. So we want to find the department, the DPD number, and also the salary. Okay, and then say, so here we have to make sure the salary is more than average. So it's greater than or equal to, and then you're trying to do the list like this. So DPD number, and then say salary, which is what salary? Average salary, AVG cell. Okay, from EMP. And then you say group by DPD number, and then you say that this will not make any sense. This will not make any sense. Do you understand? Because you cannot compare this department number and the salary. So make sure that is greater than the average, greater than this list. So on the one hand, you are given a list of things. Let me show you this. Okay, so suppose I have a couple of departments. So department 10. Average salary, let's just say is 2,000. Department 20, average salary is 1,500, okay? And department 30, average salary is 3,000, something like that, right? So you have a list like that, okay? And then on the other hand, you're trying to look for each employee. So each employee has one department, and each employee has one salary, right? So let's say 1,600. And you're trying to say this is greater than this will work, right? So you cannot do this comparison. Does it make sense? Because you really have to make sure that department is equal to department, and then only this number is greater than the corresponding department. So, for example, you look at department 10 and look at the department 10, and then you have to make sure that that salary is greater than this average. Okay, so not the whole thing is greater than. Does it make sense? So this example demonstrates that you really have to use tuple variables. Okay, so let's use tuple variables to solve this problem. Okay, and then so we'll do employee T. Okay, and then say T dot unit, and then we'll make sure that T dot salary is greater than. More than, right? Have more than, okay, greater than. So then we're trying to find average salary for T's department. So what is average salary for T's department? So we're looking at the second table. Select, let's just say, average salary AVG T dot cell and S dot cell. So we're going to use second table from ENPS. Okay, and then say well S dot EPT number equals to T dot ENP number. So that is what we're looking for. Okay. Does it make sense? So this example demonstrated that the tuple variable is the one that is more powerful than the simple subqueries. So let's run that. We find nobody, huh? What is possible? Why? Oh, we have one employee does not have salary. So this gives you some kind of wrong result. Oh, let me try to do that. Trying to delete from EMP where cell is null. Okay. That was causing. I'm going to delete it, and now let's run this query again. Still have no result. Any employee salary is more than average of their corresponding department. No, sorry. You see what happened? So as department number equals to T's department number, not employee number. So this is what? DEPT number. Okay. Okay, anyway, that salary with missing value will also cause trouble when you do average. So let's delete that anyway. So, something wrong. Let me see which one is wrong. DEPT number. I think I misspelled something right here. DEPT number. And let's do it again. So those are the employees who make more than average their department's average salary. Okay, so this kind of question is very, very useful, right? You want to find out which employees have salaries higher than their department average. Okay, so each department average is different, right? So you have to treat each employee differently, respective in their departments. All right, and now let's do last question and we'll take a break. Okay. That is example 5. So here we give 200 salary increase to the person who have the smallest salary in each location. Okay, smallest salary in each location. So again, so first of all, let's say update. Okay, let's just do the main query first, step by step, right? So we'll just do that, and then select update EMP. Okay. We can also use tuple variables when we do this. Okay, we reference use update, then do tuple variables. Okay, and then set T dot cell is equal to T dot cell plus 200. Okay. So that means add a $200 salary increase, right? Okay. And then we say, well, so what we're trying to do is we want to make sure that T, the person we are looking for, T, okay, he has a minimum salary in his location. Minimum salary in his location, right? So I will just say t.cell, okay, t.cell. So now we are trying to find out t's location. So t does not have a location, right? So we have to use some kind of subquery. Let's try to do that. Okay, let's say equal to. Okay, so now let's try to find out what's the minimum salary for this t. Okay. You say, remember we need to update, we can only use one table. We cannot do multiple tables, okay? So we cannot say comma dot, dpd, so that's not allowed, okay? So only thing we can do is, let's just say based on t's department, and then say what is the minimum salary for department for that particular location, okay? So let's try to find the minimum salary, so in of say s.cell. Okay, and that minimum salary is for this t's matching department location. Okay, so we'll do that from emps. Okay, and then we can also we can do join, can we? So join dept. Okay, so can we use another variable for s? We can. So we can just say just ts. Let's just say a. Okay. So now we say a.dept number equals to s.dept number. So that's how we do the join. Okay. So from that join, then we create a join that combines information from both department and employees. Okay. And then after that, we can use a location, okay, and say, what do we do? Well, then we just make sure that they have the same location. So we are using this department T. No, not department T. So employee T has department number only, right? Department T. Let me just try to think loudly, see how this query seems to be a little bit more difficult than I imagined. So that's t dot dept number equals to s dot dept number, something like that. Would that work? Okay, let's try to do that. Trying to think again. Okay, so I'm going to update employee. So pick up one row from employee table, and then we're trying to change the salary. Okay, and then as long as that person's current salary is the minimum in his location. Okay, so let's try to find out the minimum salary in his location. So we're trying to do minimum cell from emp. Join with join with the dept number, and then make sure that is on this criteria. Okay, these are joined. Okay, and then we are using department, matching this department. That should give you the result. However, if I'm not using location, right? So how do I use location? So if I do department, let's try to find out the location for S for this. So let's say the department number is in. Let me just try. Let me see. There's one little thing here to fix. Okay. So it's kind of. So I want to make sure that I'm using this the department where department is in the location. So let me see how can I do that? Okay, let's say department. So okay, first of all, let me run this. I think this should give you a correct result, but still we 3 rows updated, but still we do not use location here. So that's the only thing I have trouble with. So trying to say, so we have a location here. So location is department S location, department A has location, right? And then, so let me see whether we can use that. So department T, for employee T's department, is equal to S department. That's okay, right? Because we have no way to know the location for an EMP table. Or we can just say this department is in this location. So let me try to do something a little bit. Let me still keep this. And then I'm trying to think loudly, have a different solution here. Let me just say here. So department, I'm trying to make sure that this department A's location is matching this employee's location. Okay. And then we probably need to use another subquery to do it. Well, let me just do that. Okay, let's ask that location. Okay, and then we can just say equal to. Then we're trying to find out the location for the T's, for matching T's. Okay, so let's say find, select, okay, select log. So we can use another subquery, maybe. So another subquery. Let's say find the location from DPT. Okay, and where DPT number is equal to T.dpt number. That might be the way to do it. Does it make sense? So let me try to think twice. So the first part is okay. The first part we're trying to find, trying to pick up employee to update, give the salary increase, and then for as long as salary. So we're trying to find a salary, minimum salary for this employee T's location. Okay, where's the employee T's location? And this subquery will find it. Find location from DPT where DPT.dpt number equals to T.dpt number, right? So this location. And then as long as the location we are looking for, trying to find the minimum salary, right? And the location is matching that, then that's what we're looking for. Okay, so I think this is probably logically logically correct solution than this one. So this does not use an I think both give you the same result, I believe. But this one will just using location. Okay. So in the case that the department one location may have multiple departments, then this one is better. If one location has multiple departments, then this is one to go. Okay. All right, getting very complex. Now let me say, I think that will be the last tuple variable example here. And then we are going to, after that break, I'm going to do a couple of few simpler ones, okay? So we cannot always do more complex, just always going up, right? But then today, I think for today, this will be the most difficult queries we're going to write, tuple variables, okay? Yeah, and let's take 10 minutes break. 10 minutes break until 8:40, okay? Let me stop recording, see whether you have any questions. All right, so let's say we finished two subjects, okay, two lectures. One is about set operations. Second one is tuple variables, which is, you can tell that sometimes is pretty challenging, okay? And now let's do some simple ones. So first one is about copying data from one table to another table. That is actually pretty easy, okay? So we can do it in two different ways. So this technique will be used usually as a way to back up data. Okay, back up a production data to a remote place just in case there's some kind of like a disaster in the production side, and then you can always have a daily backup. Okay, so remember we when we do insert, we have to just insert one record at a time, right? So remember, insert into EMP, then values, and then you can only have one value, one record. Okay, but that of course, if you do that, you have to write some kind of program to run or to insert all the records you want to back up. Alternatively, we have another way to do it. We can just say insert into and then use select statement to get the tables. Get the results using select statement, and then those select statement will retrieve results, and all the results will be inserted into another table. Okay, so there are two ways. First, you may have existing table that you can just get data from a select statement to be inserted into the existing table. Okay, so that might be the case that you say, on my backup table, I have already have a table there. So what I needed to do is just find the records to be backed up. Okay. Another way is you can just create a brand new table from select statement. So in that case, you use a select statement to get data, and also from select statement to get columns and also data type, data structure of existing table for the new table you're going to create. Okay, so let's just use a couple of examples to demonstrate that. Okay, so first of all, I am going to use example 1 here. Okay, so let's just say question is about backup data. Okay, to another table. Okay. So example 1 is create a new table called salesman based on information in the EMP table. All right, so we would do say create table, and then is that right? Create table. So let's call the table name salesman. Okay. And then we say as, and then we try to just create a query, sub-query, which will get a result and also data structure for us to create this salesman table. Okay, so let's say for the salesman table, let's say I need the employee number, employee name, maybe a job title, okay, and also hire date, okay, and let's just also put a commission in there, from EMP, and then let's say I will do that for all salesmen. Say job equals to salesman. Okay, semicolon. So now so this is a simple query. Will give you, get the information from your employee table, and all the salesman information will be included in here, right? And then you're trying to use that table to use that result to create a new table called the salesman. Okay, let's see what the result looks like. Okay, so first of all, run this statement. So it's a table salesman created, right? And now let's just look at the table. So let's say describe salesman. So that will give you a bunch of columns and also the data type and size for each column. So employee number, number 4, employee name, worker 10, job. How does this commands give those? Right, it's getting all the information from EMP table. From the EMP table, you get a data type, size for each column you specify. Okay, so this give you the the table structure. And now let's say, what if I want to show the data inside the table? Let's just say we select star from salesman. Okay, so we will be able to see the data inside the table also. So now we see that the table has 4 rows, and all of them are about salesman. Their job title are salesman, right? And then this employee number, employee name, job, hire date, commission, all that. So belong to salesman. Okay, so after we do that, then of course you can just treat this as regular as any table and do anything, like analysis, data analysis, or whatever. Or maybe just in most time we are using that just for backup. Okay, so this is the first example, and let's do next example. Create a table called CS102, which include the students registered in computer science 1 or 2. Oh, by the way, we use example, we just create a new table inside the same account. That does not have to be. Remember, we can use like a remote use a database link to create a table in some other places. Okay, so we can say create a salesman add. So we have a database link name, and then the database can be located in any other places. So that is really the purpose of backing up, right? So let's do the next question here. So this one, we try to create a table called CS102, and that includes students registered in the computer science 1 or 2. Okay, so let's look at what table we have. Okay, so we need to get student ID, name, and also major for students, and the registered students and the classes tables. So let's look at the 3 tables here. So before we can use those tables, let's try to understand the structure of those tables. So describe students. That one we already did, right? We already know what does look like. So it has like an ID, first and last name, and major, right? Okay, now let's do the second table we need, which is registered students. Registered students. Okay. So, and the classes table. So registered students have columns like a student ID, and the department, the course number, and the grade. Now let's look at the classes table. So trying to look at the tables, look at those table structures to see how these tables are related. Okay, so apparently this one for the classes, you have department and the course number. Department and the course number, that appears to be like a primary key for courses, right? And then each class has description, has a maximum number of students, and then how many current students enrolled, and number of credits, and the room assigned. So those are the information about classes. So this is more like a gerund, right? Gerund between student and the departments, right? So that's why we spend quite a few weeks on how to design database. So we need to understand how tables are related, the database structure. Okay, and so with the understanding that this is gerund connecting between students and the classes, now we are ready to write queries for the question. Okay, so we need to create a new table called CS102. Okay, CS102, and then say as. So now we just need to find out what we need. Okay, we need select. Okay, select student ID. Student ID. So remember, we are basically using 3 tables in this case. We are using 3 tables. So we have to make sure that which table have. So we have student ID is actually or ID is named here, but the student ID is named here. So I think that should be okay. So I'll just use ID here. And then we need to get a student name. So I will use first name, last name, first name, and then pipeline, and then use single quote to separate last name, last name. And let's just say it as a name, okay? As name, and then major. So that information should be available from major. All these columns are from student table. However, we do need to get information from the class computer science 1 or 2, which is more like, I think it's a description, course title, right? So we need to use description to sort for that. So for that, we need to at least get 2 tables. So let's put those 2 tables first. From students, okay, and classes, right? At least these 2 tables, because the classes will give us information about course title, and then student ID, name, all that coming from students table. But then remember, when you use these 2 tables, then you have to include the junction table in the middle, the surrounding in the middle. Okay, so actually we have 3 tables to be included. So that will be registered students. Registered students. Okay, so we have all 3 tables. Now we have to use equal join to connect all of them. So we'll do students.id is equal to registered students. Registered students. But what's the name? Is actually called student ID. That the student underscore ID. So that's how we connect from students table to the junction table. And we need to make sure that the junction table also connecting to the classes table. So actually there are 2 primary keys, department and also course. Okay, so we are going to do classes, but department is equal to registered students at department, and same thing for course, classes dot course number is equal to registered students dot course. Okay, so now you see this question is a little bit more involved to get, because you're combining 3 tables to create like a equal join. And then after that, now we can reference to the course title. So that will be description. Description is equal to, so let's just say, what is the computer science? Computer science 102. Look at that. Okay, so let me just try to, I think, is that big enough for you to see everything? So let me just put it like into separate rows. Okay, so then everything is in one view. So we create tables. So the difficulty part was this select query. Select query, basically, in this case, we are combining 3 tables. Okay. All right, now let's run it. I hope there's no errors. And if there's any, we will fix it. We do have error. So inside invalid identifier, there's something called student ID is not recognized. Registered students. Oh, there's a students. Okay, students. That student ID. Okay, so remember the name. Let's see, which is student ID, which is correct. Classes, the department. Let's run it again. Okay, so table created. Now we can look at the structure of the table. Describe CS 102. Okay, so we have 3 columns like that. And now let's see whether we have any data in. Let's look at data inside. Select star from CS 102. Select. Okay, run it. So we have those students, student ID major, and those students are enrolled in this class. Okay. All right, now let's do next example. So example 3. So this time, let's say I want to copy all clerks, salary, column, department, column, and job into temp table. Do I have a temp table? I may not have a temp table. Let me see. Okay, so let's say describe temp. May not have that table, but you can use the query, use that script to generate that if you have to. Okay, it does not have that, right? Object does not exist. Okay, so we cannot do that. So let's just try and do something a little bit different. So let's just say I want to try to copy all clocks information to the table we just created. Okay? So all clocks, what do we do? Name, yeah, ID, name, and what? Name and the hire date, and the commission into salesman table. Okay, we already have a table called a salesman, so we can just do that. Okay, so this time we already have a table that we need to copy to copy data into. So we will just simply use insert into and then salesman. Okay, and then you just simply use select statement to get all the information you need. So remember, we get employee number, employee name, and the job, right? And then what, hire date, and the commission from EMP, and then say, well, job is equal to clock. So even though this time they are not salesmen, but I'm just trying to use this as an example. Okay, so insert all the clocks information into a salesman table. So remember the syntax here: insert into, just same as regular insert. There's no as, okay? Unlike this create table, there's as here. And then for regular statement, you can only insert one record at a time. So you say values, blah, blah, comma, 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 those values, right? So that's just one record. Here, you can actually get multiple records, okay? And insert into this table. Insert into any backup table, actually. So let's run that. So we have some kind of error, I think. Table view does not exist. Really? Insert into salesman, I thought the table we already created. Does name mismatch? Let me see. Salesman. I think that I misspelled the salesman here. So let's just do that again. So salesman. Okay. All right. So 4 rows inserted, and now we can look at the table again. Select star from salesman. You now notice that arrow here. So now you get more rows. So some of them are clocks. So the clocks was just created in here. Okay. So let me move on. So I'm going to delete the 2 tables I just created. Job table, salesman, and then job table, CS 102. Okay, there we go. So this is a pretty Pretty simple stuff, right? Good. All right, now let's move on to our last subject for today. Do we have time? I have like 10 minutes. Do not have a lot of time, actually. So let me see. Let me see what we can do here. So we use lecture 4 is basically just trying to, we cannot do text source. Text source we'll have to do, we'll postpone to next week. Okay. So we will do just lecture 4. So functions. So we learned how to do sysdate. We already did that, right? And then MVL function, upper, lower, we did that. And toDate, toChar, we already know how to do those. And now let's just do 3 more functions. We'll do decode and soundx. Okay, soundx. So MVL I'm going to skip. Now let's try to do those examples. I'm going to skip. Okay, given the limited of time we have. Okay, so let's do soundx. And the contents, actually, we have to do. So contents is related to how to do text source. So we can just postpone to next week. Okay, so we do soundx first, and then we do decode next. Okay, so we do these 2 functions. So what is soundx? Soundx actually allows you to search for something based on sound of a column value. Sound of column value. So for example, if I just trying to say I want to find employees whose job title sounds like clock, okay? So this is how we do it, okay? So we'll do, okay, soundx, okay, for matching column sound. So entire column value sound, okay, column value sound, okay? So let's say if I want to find employees who has a job title sounds like clock. Okay, so we'll do select and then say ename from emp, and then this time we have to use soundx to interpret the sound of the column. Soundx of job title equals to soundx of say clock. So you're comparing the sound of the column value with the sound of the word you're trying to compare. Okay. And then next class we're going to text search, and then we actually can search sound inside the word, inside the column. So you have the column may have multiple values, maybe just like an article, maybe just like a new or a book, or the entire book. So you're trying to search based on the sound of certain words, and that would be different. But here we are comparing the sound of entire column value equal to the something. Okay. So if you want trying to get a job title displayed, and you will see what it looks like. So a clock, right? Clock sounds like a clock. So that's how the soundx will be used. Okay. Pretty simple, right? Okay. Next, find a job sounds like a salesman. That's pretty much the same thing, right? So I'm going to just do that quickly. Okay. Select job from emp. Well, the job title look like a salesman. So sound x of job equals to sound x of salesman. Okay, so that's simple. And next, let's try to do a function called decode, which is a little bit more involved. So decode function. Okay, so decode function is more like in Excel. I think there's a function called like a if else function. So it's kind of like that. So let me show you a basic use of that. Okay, let's just say I want to use decode to decode the certain value. Let's just say, for example, I want to decode job title. Okay, decode job title. So if job title is salesman, I will decode that as 1, and otherwise I will decode that as 0, something like that. Okay, so in that case, we are going to use that function applying to job title column. Okay, so decode job title into 1 if it is a salesman. Put a salesman here. Okay, and 0 otherwise. Okay, so let's do that. So select. Okay, I'm going to just decode. Okay, job. Okay, and then let's just say if job is salesman, so salesman. Then you change to 1, otherwise is 0, and then that's the S job code from EMP. Okay, so we're using this function. So basically, this is more like a if-else statement, right? So if we're trying to do, let me try to explain that here. Let's run this first, and then we'll do explanation. Okay, so you get 0, 0, 1, 1, right? So what does this do? Is just like a if-else statement. So let me just do it here. Let's use a whiteboard. Okay. So decode, that's a job, that's a salesman, and then 1 and 0. So this is equal to this. Okay, this function, the whole thing will give you 1 if job is equal to salesman. Okay, and otherwise. So that means the job is not a salesman. You do everything else. Okay, and this function can be nested to create more different code. So let's just do one more here. Okay, and then I think we should stop. So let's say I want to decode a job to 0, to salesman to 1, and also clock to 2, and then everything else to 0. Okay. So in that case, we will be doing just nesting decode inside. So select decode. Okay, so I'm still doing the job. And then if it is salesman, then I'll change the code to 1. Okay, so this does not have to be, text or number. You can just switch around. Okay, so for example, you can for example, department number, you can encode that as department name, okay? And then everything else is supposed to be 0 here, right? So we said the previous was 0, but now I can replace that by another decode, D-E-C-O-D-E, okay? And then say job, let's just finish this first, okay? Finish parentheses first, okay? And then close that, all right? And then as Java code from EMP. Okay, and then after that, we come back to finish this nested code. Okay, so here we are looking also job title, and now if job title is clock, and then now we change to 2. Otherwise, 0. So this is 2 layers, and of course, for this otherwise, you can do another decode. You can have more layers, right? So I'm going to just do sum here. Okay. All right, so now you have clocks interpreted as 2, and salesman is 1, so you have 3 layers, right? So for data analytics, you see that this is very important because a lot of times when you have like a text variable values or value like a male, female, you often have to code it as a 1 and 0, right? For before you do data analysis, and this decode will be very useful for doing that, right? Okay. All right, I think we are getting to the end of the class. We have 3 more minutes. Let me see whether you have any questions. Take a look at your homework to see whether there's any questions that you think that is difficult or maybe confusing. So I'm going to stop the recording for now.